Hi, today I'm going to talk about stress and strain at a point. This is comes under Unit 1 Stress and Strain of Mechanics of Solids, Department of Civil Engineering. So, let's talk about the content. So, what we are going to study here is in this slide is what is known as stress and what is known as strain. If an external force is acting outside the body, some internal resistance to oppose the external force induced in the body, in any body. Okay, so because of the external force acting, some changes in the body will occur, and maybe it termed as deformation. To resist that, internal forces are acting at its maximum to resist this deformation. This process is known as stress. And because of the stress, the deformation is occurring, that is change in the either in the length or in the dimension in the body occurs. Because of the stress, strain of in the body occurs. And what is strain is change in the dimensions of the body permanently is known as strain. So the measure to measure the amount of deformation in the material because of stress is known as strain. So, strain is the measure of the amount of deformation that occurs in the material due to stress. Hope you understand what is stress and strain. Okay, so next thing, there are different types of stress actually. That is, there will be different types of external load acting in a body. What type of the external loads that are acting? These are differentiated like different types of stress. So first one is tension stress. Very simple. What is tension stress is? If you can, if you keep a rubber band and we stretch like this, what happen? Axially we are stretching it, so changing length will occur and come back. And when we are not giving any force, it comes back to its original position. So when we are giving force by stretching, this stretching force is known as the external load. This is known as tension. And this tension stress occurs when force acts outwardly. For rubber band, we are giving a force outward direction. Okay, axially. So elongation will happening. And this elongation is happening is known as the tension stress. Okay. For example, saying rope under tension. Rope is pulling by two persons in the opposite direction is also known as tension stress. Okay. So normally the formula of stress is the acting force, the force that is acting divided by the cross-sectional area of the material. So tension force is the force acting divided by the cross-sectional area. Another type of stress is compression stress. In tension stress, the force is acting outwardly in opposite direction it is acting, that is known as compression stress. Simply the force acting inwardly is known as compression stress. So what happened, the deformation will like this. Elongation, the length get increases. During compression, the length get decreases. So compression stress occurs when force acted inwardly on an object trying to shorten or compress it. Compressing it is known as compression stress. For example, the pier in a bridge is a very good example of compression stress, and that we are looking that can be see in any areas like over the any bridge area in the roadside. Okay, we are going across under the bridge, we can see so many piers, and in between the above to that pier there is deck, and this because of the deck compression stress is happening. Okay. Hmm? Uh, so again the formulas of every stress is equal, the force acting divided by the cross sectional area, we will get the stress. Okay. Another thing is shear stress. Shear stress is the forces acted parallelly to the surface of an object, causing different layers of the material to slide past. Different layers is sliding past, either this side or this side. This is known as shear stress. Okay. So cutting a piece of paper with scissors or the movement of tectonic plate. For very good example is the tectonic plates. Everyone will know what is tectonic plates. You should have studied in social. So because of this tectonic plates theory, the earth surface is elongated, or because of the shear, because of something, this external force, because of the external force acting in two directions, a material will be like this, and external force is acting in two different directions, so it will be like this, and it is known as the shear stress. Same formula, shear stress is equal to the shear force divided by the area of the face. Area, not cross section area, it's area, simply the area of the face. Okay. Next comes the stress and strain curve. So every material is different. Steel is different from concrete. Concrete is different, the steel itself different, Tor steel is there. So every steel also, there are different kinds of steel, so the properties may change. Because of the change in properties, the stress and strain curve is different for different material. But the common thing a material undergone during stress and strain is certain common things will undergo by the material, that we are going to see in stress strain curve. For any stress strain curve, when an external force is acting, depending upon the external, how much external force acting, there will be some changes occurs in the body of the material. That stage we are going to explain in the stress and strain curve. So first comes the point A, that is elastic limit region. In elastic limit region, if a body changes its length or its width, whatever, after the external force acting, if the external force is no more acting, means the material comes back to its original position. Still it has the ability that the material come back to its original position in the elastic region state. Okay. So during the elastic state, elastic limits region, when an external force is not acting no more in that body, it comes back to its original position. Okay. Next thing is, so this is also known as Hooke's law. Okay, according to Hooke's law, stress is directly proportional to strain, and within that elastic limit only. Within that elastic limit only, stress is directly proportional to strain. Here comes the Young's modulus. Okay. When a material, we are giving a small amount of external force, it undergoes some deformation. But it can retain its original shape when the stress is removed, that is external force is removed. This phase, it is the material like a, for example, the material like spring, elastic band. It can have to store elastic potential energy, it can store and come back to its original position. Okay, so according to Hooke's law, stress is directly proportional to strain. What the important thing is, within the elastic limit only, within the elastic limit only, in that stage only, stress is directly proportional to strain. Young's mode and the modulus of rigidity, sorry, modulus of elasticity, Young's modulus of elasticity is different for different material actually. For steel and concrete, it's entirely very different. Okay. Next comes the yield point. So The yield point is the stress value beyond the material undergo permanent deformation. In elastic region, material comes back to original position, but in yield point, material permanently deform. They won't come back to the original position if the stress or the external force is removed. So once the materials passes this yield point, so the plastic deformation region it occurs. That means the change in the shape of the material will be permanent. And yield point for different material is very different. Is entirely different. Some materials may be ductile metals. It won't show yield point. It's a yield plateau. Like there will not be some more changes. There will be some more changes. So this plastic deformation is nothing but the material won't come back to original position, and it gains another shape. Okay, that is known as plastic deformation region. Okay, so another thing is the I already explained about plastic deformation region. The changing in the shape of the material occurred actually. So it goes to the plastic stage, that is permanent deformed stage. So the material is now permanently deformed. Its ability to gain the original shape is lost by the material. So the material no more act like elastically. It's going to change to plastic. So that is known as plastic deformed region. Then next comes the ultimate strength, tensile strength. Ultimate tensile strength is the highest point in the stress strain curve. The maximum stress a material can withstand before the breakage occur or fracture or failure of a body occur. That is the ultimate tensile strength, beyond which the material will no more occur, or the ability to no more withstand to that stress will not be there. So after the ultimate strength point, tensile strength, what happened? Failure of the material happened. So ultimate tensile strength is nothing but the maximum stress a material can withstand is not known as ultimate tensile strength. Sorry, ultimate tensile strength. Okay. So when a material reaches its ultimate tensile strength, next will be the fracture point. Of course, the material fails to withstand in that stress. The fracture point is the stress value at which the material fails. They don't have any deformed shape. It completely rupture or fracture will occur. So separate two pieces will going to break into two pieces. The material can no longer support in any additional stress, and it breaks into two or more pieces. This is known as fracture point. So in stress strain curve, we studied about the different, this is normal stress strain curve, this is the normal thing. So different material have different stress strain curve. Okay, this different stress strain curve, and this is the common of the stress strain curve, common behavior of the stress strain curve of a material, any material. This is a common behavior. These stages, a material will undergo these stages, like elastic region. After that comes yield point, then it comes to plastic deformed region, then ultimate strength and the fracture point. Every material will undergo these kinds of stages. Okay, so the stress strain curve provides valuable information about the material because of the mainly it comes of the mechanical behavior. It includes the strength of the material. We can know the ultimate strength. So the strength of the material, ultimate strength of the material we will get. the stiffness of the material, ductility, brittleness, every information we will get from this stress strain curve. Okay. By analyzing the stress strain curve, engineers can make informed decisions about the material selection, which material we can able to use for what kind of projects. Okay, the selection of materials we can choose by using this stress strain curve. That is the usage of the stress strain curve. Uh, so we are in inside uh, we are using some materials for reinforced concrete. uh, okay, so in that what so the type of material choosing is depends on the stress strain curve, because it gives the information that how much strength it can acquire. Sorry. The stiffness, ductility, the brittleness of the material, every information we will get from the stress strain curve. And the stress strain curve of different material is different. So this is the usage of the stress strain curve in the site. So by analyzing stress strain curve, we can choose right material for the right projects. Hope you all get to know what is the meaning of stress, what is the meaning of strain, and how is stress and strain is related, and get to know that different stages of stress strain curve, and get to know what is the importance of stress strain curve in the in civil engineering or in the projects. Thank you.